Welcome to this episode of Robert's Creative Chronicles. So today we'll be solving this question, which states that the equivalent circuit impedance of a 20 kVA 80,000 by 240 volt 60 Hz transformer are to be determined. The open circuit test and short circuit test were performed on the primary side of the transformer and the following data were taken. This is the open circuit test data. This is the short circuit test data. This is the voltage, the current, and the power for both open circuit and short circuit tests. Find the impedances of the approximate equivalent circuit referred to the primary side and sketch the circuit. So let's start this. Solution. Now the first thing we are going to find is the power factor during the open circuit test. So the power factor during the open circuit test is given by cos to cos theta, which is cos to the open circuit power over the open circuit voltage times the open circuit current. So now this is equal to the open circuit power is this times 8,000. This is the voltage, the open circuit voltage. Then the open circuit current is what? 0.214 ampere. This is 0.234 approximate. That is to 3 decimal places. So 0.234. And during open circuit test and short circuit test, the power factor is always lagging. The power factor is always lagging. So this is lagging. Because during open circuit test and short circuit test, the power factor is always lagging. So it's 0.234 lagging. So now the next thing we are going to find is the excitation admittance. The excitation admittance is given by this YE is equal to current, the open circuit current over the open circuit voltage negative cos inverse power factor. This is the formula for excitation admittance. So now the open circuit current is 0.214. The open circuit voltage is 8,000. The power factor is 0.234. So this is 2.675 times 10 to the power of minus 5. So now we can write it. Let me move out a little bit. So this becomes what? 0.0000268. That is approximately 268. And this is what? 1, 2, 3, 4, 5. Then angle negative cos inverse 0.234. This is negative 76.5 approximately. This is negative 76.5 degrees, and the unit of admittance is ohm. But this is a polar form of admittance. We can convert it to the rectangular form which we need. So to do that, we will change the mode to compress mode. That is 2, mode 2. Then you take this. This is 0.0000268. Then you press shift. After you press shift, then you press this. You see this is the sign that's here. So you press shift and press that. So you press shift and this. So you press shift and this one, you see. Then you write the angle, which is negative 76.5, and you press equal to. You see, the answer is now in rectangular form. So this is what? 6.25 times 10 to the power of minus 6. So this is equal to what? That means the zeros are 5 to be 0.0000 and 0. Then 6, 3 approximately. That is, you round up these two to 3 approximately. Then the other ones, there's minus. Then this is 2.6 or 2.61 times 10 to the power of 5. And there is, you see this I. This I is the same thing as J. So you can write either I or J. This I or J is a complex number. It's the root of -1. So now this is, there are 4 zeros here. 0 plus 0.0000, 0.0000, then 261 approximately. So this is what? 1, 2, 3, 4, 5. You see? So this is the rectangular form. Now, this is the excitation admittance. But this admittance is also equal to this 1 over RC minus J 1 over XM. That means the real part of this complex expression is equated to this, and the imaginary part will be equated to this. So now we can conclude that 1 over RC is equals to this 0.00000 1, 2, 3, 4, 5, 5 zeros 6, 3. That means RC is equals to 1. When you rearrange, it becomes 0.0000063. So the inverse of this, which is 1 over this, is RC. Zero point zero 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 63 is 158730. So we can express this in kilo ohm. So if you convert this number to kilo, that is, you divide by 1000, we will get 158.730, and if we approximate it to be 159 kilo ohm. So RC (159 kilo ohm). So RC is 159 kilo ohm. Then to find XM, we equate it, so it becomes 1 over XM is equals to what? 1 over XM is equals to 0.0000261. So this is approximately equal to xm 1 over what? 0.0000261. So it's 40261. Here is 38. This is 38.3 kilo ohm approximately. So we have found XM and RC. So now we are going to find the power factor during the short circuit test like we did here. But here is the short circuit values that we use. Power factor is equal to what? Cos theta, which is equal to, this is the short circuit power over short circuit voltage times short circuit current. So what's the short circuit power? Is 240 over 489 times 2.5. So this is 0.196 and it's lagging. This is 0.196. So now we are going to find the series impedance. It's given by this formula. So this is the formula for series impedance. So voltage is what? 489. The current is what? 2.5. The power factor is 0.196. This is 195.6. Then cos inverse 0.196. This is 78.7. So now in the same way as we did here, we will also repeat that same procedure here. So this becomes what? Compressed mode 195.6, 78.7. This is what? 38.3 plus 192, or there's a complex number J, 192 ohm. Here also is ohm. So this is the series impedance. And this series impedance is also giving us the equivalent resistance plus J, then equivalent reactance. So now if we compare these two equations, you can know that this is the equivalent resistance and this is the equivalent reactance. So we can conclude that the equivalent resistance is equals to 38.3 ohms and the equivalent reactance is what? 192 ohms. So the equivalent resistance is 38.3 ohms and the equivalent reactance is 192 ohms. And finally, the question says, find the impedance of the approximate equivalent circuit referred to the primary side and sketch the circuit. So now we are going to sketch the circuit, which is the approximate equivalent circuit referred to the primary side. Note there is an approximate equivalent circuit referred to the secondary side. But here in this question it states here in this question it says the approximate equivalent circuit referred to the primary side. So we are going to draw that one. So now let's draw the circuit. There will be the equivalent resistance here, the equivalent reactance, so now here will be the primary current, IP. Then here is the primary voltage, VP. So since this is the approximate equivalent circuit referred to the primary side, here becomes IS over A, that is the secondary current over A. Then here also becomes A times the secondary voltage. So now here is the equivalent resistance. So now the equivalent resistance is 38.3. So here becomes what? 38.3 ohm. Then here is what? J 192 ohm. Here is what? RC. RC is 159 kilo ohm. And here is what? Here is what? J XM is 38.3 kilo ohm. So RC is 159 kilo ohm. XM is what? Is 38.3 kilo ohm. Equivalent resistance 38.3 ohm. And this is 192 ohm with J. So this is the sketch and this is the workings, the calculations. So that's all for this. I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email it in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share and subscribe to my channel and hit the notification bell to get notified as soon as I drop a new video. Thanks.